All right, so today we're working on graphing quadratics in Vertex form. Let me get my pen up here. All right. Okay, so to find the vertex HK, right, HK, use the opposite value for H and leave K as it is. Do not apply the exponent to anything. This is significant, all right? Don't ignore the exponent. All right, so literally we are just looking. So this is H, that's a -8, so we're gonna take the opposite, that's +8. This is K, we take it. That's my vertex. Simple, easy, ignore the exponent. All right, this is my H, opposite of that is my X. This is my Y. Ta-da. All right, very simple. We have our vertex form. So let's discuss what this means for graphing it. And let's start with the parent function. All right, this is y equals x squared. If you're looking at this, you're noticing that it's missing some parts, right? It doesn't have the h, it doesn't have the k. So what do? Well, we can write in zeros, right? And this is exactly what we've done here. Y equals x minus 0 squared minus 0. So my vertex, I take the opposite of h for my x. Is there such thing as a -0? No. So it's just 0. Use k as my y. So my vertex is at 0, 0. All right, now we need points. And the easiest way to do this is to actually evaluate. So we're going to actually plug in. Remember we did an XY table last time? So we're just going to do 1, 2, 3. All right, so if I plug in 1 for x into this, 1 squared is 1. If I plug 2 in for x, 2 squared is 4. If I plug 3 in for x, then 3 squared is 9. All right, we get 149. And I want you to use trick this 149 is going to be super amazingly important. We're going to use this every time we graph. All right, so starting at the vertex, I know I go 1 in the x direction, and I go 1 in the y direction. See this? 1, 1. Then I go 2 in the x direction, 2, and I go 4. 1, 2, 3, 4. All right, my next coordinate was 2, 4. Then I go 3 and 9. Now remember we said 0, 0 was our vertex, right? And remember the vertex is the mirror point. So we're going to graph the same thing on the other side. So if I were to plug in -1 here, see how I get 1? So -1 squared is 1, -2 squared is 4, -3 squared is 9. So it's a perfect mirror right down the center of this vertex. Then we draw our parabola. All right. Okay, the following properties exist when making comparisons to the parent function. All right, if a is positive, all right, looking back at this, a right here, if a is positive, the parabola opens up. If a is negative, the parabola opens down. If a is 1 or -1, it's a standard shaped parabola. If a is a proper fraction, so smaller than 1, the parabola is wide. If a is a whole number or an improper fraction, so larger than 1, the parabola is narrow. All right, so once you've established your vertex, use the opening, stretch, and shift to graph the parabola. All right, so looking at this, vertex, once again, opposite of h, -1, use k, -3. All right, next one is asking me for a minimum and our maximum. More on that in just a second. First, let's go to this next one. Does the parabola open up or down? Well, my A here is a ninja 1, it's a positive, which means that it's going to open up. So what does one that opens up look like? Like this, right? So it's asking about my vertex being a maximum or a minimum. My vertex is here. That's the lowest point. So that's going to be a minimum. All right, the stretch here is 1, so this is standard. The shift, all right, this goes back to my vertex. Remembering that the starting vertex is at 0, 0. All right, if our new vertex is at -1, -3, then I shifted left 1, and I shifted down 3. Left 1, down 3. All right, and now this is where our 149 table comes in. All right, you remember when we plugged in x is 1, 2, 3? All right, we're going to put in our 149. And I'm going to show you this is going to act like navigation directions. So 149 is for a standard A of 1. Our A is 1 here, so we're still going to be 149. All right, so navigation directions. Okay, remember this is when X is 1, X is 2, X is 3. So if I go 1 in the X direction from my vertex, I have to go up 1 in the Y direction. That's what this says. If I start at my vertex and I go 2 in the X direction, I have to go 4 in the Y direction. 1, 2, 3, 4. That's what this says. If I start at my vertex and I go 3 in the X direction, I have to go 9 in the Y direction. So 4, 5, 6, 7, 8, 9. And I mirror the same thing on the other side. And there's my parabola. Okay, D is more of the same. Let's go down here and let's look at G. All right, because I want to show you one where the A is actually different. Okay, first off, we're trying to find our vertex. So we take the opposite of this. So -4, and I don't have a K. How do we say nothing in math? Yeah, it's +0. So for -4, 0. My A here is positive, so this is going to be a minimum. And the parabola opens up. My stretch, this is bigger than 1, so it's narrow. My vertex is -4, so I shifted left 4, and 0, so I shifted none in the up and down direction. All right, so now we're going to use my 149 table. All right, remember, this is when X is 1, 2, and 3. All right, and then my A is 2. So we're going to multiply my 1, my 4, and my 9 times 2. So 2 times 1 is 2. 2 times 4 is 8. 2 times 9 is 18. So let's start graphing. So my graph is at -4, 1, 2, 3, 4, 0. When I go 1 in the X direction, I have to go 2 in the Y direction. All right, so if I go 1 in the X direction, I go 2 in the Y direction. Okay, if I go 2 in the X direction, I have to go 8 in the Y direction. 2, 8, 2, 8. All right, and if I went 3 in the X direction, I'd have to go 18. My graph doesn't cover that. All right, so now I draw my parabola. Super easy. Let's look at H, because I want you guys to get practice with this fraction here. All right, so my vertex, opposite of H, so -2, K, 5. All right, vertex, does the parabola open up or down? Well, it's a negative, so it opens down. That makes this a maximum, because it's going to look like this. All right, the stretch, this is a -1/4, so it's a proper fraction. It's going to be wide. My shift, I went left 2 and right and up 5. All right, so let's go. Left 2, up 5, 1, 2, 3, 4, 5. Let's make my 149 table. 1, 4, 9. Remember, this is when X is 1, 2, and 3. All right, this is A. My A here is -1/4. And we're going to multiply what my A value is times 149. So 1 times -1/4 is -1/4. 4 times -1/4 is -1. 9 times -1/4 is -9/4. Just for ease of graphing, I am going to do what I tell you all not to do. I am going to convert this into a mixed number, which is -2 and 1/4, just because it's going to be easier to graph. All right, so let's graph this. Starting with this, starting with my vertex, I go 1 in the X direction. I have to go -1/4 in the Y direction. All right, my graph is really small and my pen is really big, so that's going to be as close as we can get. All right, when I go 2 in the X direction, I have to go -1 in the Y direction. All right, when I go 3 in the X direction, I have to go down -2 and 1/4. All right, so 3, down 1, 2, and 1/4. All right. And then I could draw my parabola. Do you see how this one's much wider? All right, and that's my graph. Okay, so now we got one last thing we got to do. We're going to compare two quadratic equations in vertex form to each other. All right, so looking at this, we're going to compare the opening. This one's negative, this one's positive, so the opening is definitely different. The stretch, Well, I went from a negative 1/3, so a really wide one, to 2, so a narrow one. So this went wide, one wide, two narrow, so it is definitely narrower. The shift. All right, so I went from a vertex here of -3, 7, to a vertex of 1, -4. So how did I move? I went from -3 to 1. So I definitely shifted right, and I shifted right how many? 4. I went from 7 to -4. So I definitely went down, and I went down 7, 8, 9, 10, 11 places. And that's all we're doing here. We're just comparing and counting. All right. All right, next one, opening, same or different? Well, that's a positive 1, that's a positive 7/2. It's the same. The stretch, I went from a standard 1 to a 7/2. Remember, 7/2, that's bigger than 1, so this is going to be narrower. All right, my shift, I went from -2, 1 to -3, 1. So I went from -2 to -3, so I definitely shifted left 1. And I went from 1 to 1, so I didn't shift up or down any. All right, last one. 2, 7/2, both positive, opening is the same. The stretch, now this is where it's asking. I went from 2 to 7/2. So let's get 7/2, let's get that into a mixed number so we can directly compare it. So 2 goes into 7, how many times? 3, so 3.5. So this is a bigger number. So I got narrower. All right, my shift, my vertex is 2, -4. And the new vertex is -5, -5. So I definitely went left. I went left 7. And I went from -4 to -5. So I went down 1. All right, and that is all for today. As always, if you have any questions, send me an email, and good luck with your homework.